Okay, good morning everyone. Today I am going to discuss about the computer networks. So unit 2, coming to the topic, that is data link control, DLC service, data link control. So what is mean by data link control services? So in this we are having two main functions of the data link layer. So in the data link layer we are having two main functions. So that is data link control and medium access control. So in the data link control services we are having two main functions, that is called data link control and medium access control. The first one, data link control, deals with the design and procedures of our communication between two adjacent nodes. So what is mean by data link control? So the data link control deals with the design and procedures for communication between two adjacent nodes, that is node to node communication. So in the data link control the functions include framing, flow and error control, and software implemented protocols that provide smooth and reliable transmission of frames between the nodes. So in the data link control we are having some functions, that is framing, flow control and software implemented protocols, and that provided smooth and reliable transmission of frames between the nodes. So in this we first discuss about the framing, and next we can discuss about how to organize the bits that are carried by the physical layer. So in this we are going to discuss about the, and another is flow and error control. So what are the those things we are going to discuss in this data link control so we are going to discuss about the three types of services, that is framing, organizing of bits are carried by physical layer, and flow and error control. So these are the different things I am going to explain in this data link control service. So in the data link control, so each protocol is a set of rules that need to be implemented in software. So in the protocols we are having the set of rules. So what is mean by data link control so data link control అనేది two main functions ఉన్నాయి. అదేంటంటే data link control and medium access control. సో డేటా లింక్ కంట్రోల్ దేన్ని డీల్ చేస్తుందంటే డిజైన్ అండ్ ప్రొసీజర్స్ ఫర్ కమ్యూనికేషన్ బిట్వీన్ ద టూ అడ్జసెంట్ నోడ్స్కి మధ్య కమ్యూనికేషన్ని అక్కర్ అవ్వడానికి మనం డేటా లింక్ కంట్రోల్ అనేది యూజ్ చేస్తాము. దాన్ని ఏమంటారు అంటే నోడ్ టు నోడ్ కమ్యూనికేషన్ అంటాం. సో డేటా లింక్ కంట్రోల్లో కొన్ని ఫంక్షన్స్ ఉన్నాయి. సో మనం ఏ ఫార్మాట్లో మన డేటా అనేది ఉంటుంది, డేటా లింక్ కంట్రోల్లో డేటా అనేది ఫ్లో ఎలా ఉంటుంది, ఎర్రర్ కంట్రోల్స్ ఏంటి, ఇవన్నీ అనేది దీంట్లో డిస్కస్ చేస్తాం. సో దీస్ ఆర్ ద functions of the data link control, that is framing, flow control and error control. So first we are going to discuss about the framing, and we are going to think how to organize the bits in the carried by the physical layer, and next I will discuss about the flow and error control. So these are the topics we are going to these are the services of the data link layer we are going to discuss now. So whenever the data link protocol, the protocol is nothing but it contains the set of roles that need to be implemented in software and run the two nodes involved in the data exchange or the data link layer. So what is mean by protocol protocol లో మనకి సెట్ ఆఫ్ రూల్స్ ఉంటాయి. ఆ రూల్స్ని ఎవరు ఫాలో అవుతారు, సాఫ్ట్వేర్ అనేది ఇంప్లిమెంట్ చేస్తుంది. ద సెట్ ఆఫ్ రూల్స్ దట్ ఆర్ నీడ్ టు బి ఇంప్లిమెంటెడ్ బై ది సాఫ్ట్వేర్ అండ్ రన్ ద నోట్స్. టూ నోట్స్కి మధ్య కమ్యూనికేషన్ని జరగాలంటే వీ హ్యావ్ టు ఫాలో సమ్ ఇన్స్ట్రక్షన్స్, దట్ ఈస్ నథింగ్ బట్ protocols. It is a set of rules that will be implemented by the software, and the two nodes will be involved to exchange the information in the data link layer. So in this we are having the 5 protocols, that is two noisyless, that is called ideal channel. So we are having the 5 protocols in this data link control. We are having 5 protocols, that is called the noiseless channel and noisy channels. So 2 వచ్చి noiseless channels ఉంటాయి, 3 వచ్చి noisy channels ఉంటాయి. So those in the first category or not, those are the first category are not actually implemented, or not actually implemented but provided the foundations of understanding the protocols in the second category. So this is a data link control. So in this data link control we having the framing. So what is mean by framing? So in the last class we have discussed, if you see that video you can understand. So again I am recollecting these points coming to the framing. Data transmission in the physical layer. So whatever the data available in the physical layer, in the which format bits format, that bits format is moving from the signal to the source to destination. So framing lo manaki first enti data physical layer. సో ఫిజికల్ లేయర్ మనకి 7 లేయర్స్ ఉన్నాయి. 7 లేయర్స్ నుంచి లాస్ట్ లేయర్ అనేది ఫిజికల్ లేయర్. అందులో మనకి బిట్స్ కన్వర్షన్ ఉంటుంది డేటా అనేది. సో ద బిట్స్ కన్వర్షన్, ద బిట్స్ ఫామ్ విల్ బి ద బిట్స్ ఇన్ ద ఫార్మ్ ఆఫ్ సిగ్నల్ ఫామ్లోకి కన్వర్ట్ అయ్యి బిట్స్ అనేది ఫ్రమ్ వన్ సోర్స్ టు డెస్టినేషన్, ఇట్ రీచ్ టు సోర్స్ టు destination. The physical layer provides the bit synchronization that are send and receive use the same bit duration and timing between the source and the destination. So on the other hand, we needs to pack the bits into frames. So in the physical layer our bits format in the form of bits. Okay na, the format of the data is in the form of bits. If you talk about the data link layer, in this we are having the data will be frames. Okay na, each frame is distinguished from another. So framing in the data link layer separates the message from one source destination to another, one source destination to another. So whatever the framing of in the data link layer, we are having the message, that message moves from one source to the destination, or to or other message to another destination. So by adding a sender address and destination address, so whatever the data we are sending from source to destination, that the data will be included the address of the source and destination. So that it distinguish the address where the packet is go. So where then depending on the address we are going to identify where the packet is came from, the which source is sended. So that is because depending on the address we can identify that. So the sender address helps the recipient acknowledgement and recipient the recipient through the whole message could be packed in one frame. That is not normally done. So this is that the frame can be very large, making flow and error control very inefficient. So what is mean by flow control and error control? So due to the overflow of data between the source and destination, we are using the flow and error control. Due to the overflow of data, our data will be collapsed or lost. So in order to overcome that, we are using the flow and error control. So the message is carried in one very large frame. So in a single bit error, that would require retransmission of whole message. So when message is divided into smaller frames, a single bit error affects only the small frames. So this is called the framing. In the framing we having some different formats, that is fixed size framing, variable size framing. So what is mean by fixed size framing? In a frames that are fixed or variable size. So in the frame, whatever the frames we are using, the frame we are taking a fixed size. So in this fixed size framing, there is no need to define the boundaries of the frames, and the size itself can be used to delimiter. And for example, this type of framing is ATM wide area network, which uses frames of fixed size called cells. So this is called the fixed size framing. Next, coming to variable size framing. So what is mean by variable size framing? In the variable size framing, local area networks. So we are prevalent in local area networks. In variable size framing, we need a way to define the end of frames and beginning of the next. So what is the use of the variable size framing? So the end of the frame and the beginning of the next. Two approaches were used, that is character oriented approach and bit oriented approach. So in the variable size framing, we are using two types of approaches, that is character oriented approach and bit oriented approach. So next, coming to the character oriented approach. So this is the framing diagram. So in this framing diagram we are having the flag, header, and this empty boxes contains the variable number of characters, trailer and flag. So at the end and at the beginning and end of the frame we are using the flag. So what is mean by flag? It is the indication for start and end of the frame. So that is called the flag. Next, header. Header will contain the source and destination addresses as well as the other control information. So and data from the upper layer. So next coming to trailer. So this trailer is called error detection and error correction code. Error detection, error will be detected and correct the code. So these are the different things available in the format of frame, in the frame. So next coming to character oriented framing, that is called byte stuffing. So in the character oriented protocol, data to be carried for 8-bit characters from a coding system such as ASCII. So at the header side, this is the diagram. So if you see this diagram, we can understand the explanation of this character oriented framing, that is byte stuffing. In the header side, so which is normally carries the source and destination addresses and other control information. So we already told that what is the use of header. So in the header we contains the source and destination addresses and other information, other control information, and the trailer which carries the error detection and error correction redundant bits, and also having the multiple 8 bits to separate one frame from next, to separate one frame to next frame. So the 8-bit, that is 1 byte flag, is added at the beginning and end of the frame. So what we are doing, so at the tiler we are going to carry the error detection and error correction redundant bits. It also having the multiple 8 bits, and it to separate the one frame, we have to separate one frame from the another. Next, we are using the 8-bit, that is 1 byte flag. So it is added at the beginning and end of the frame. Why we are using flag, it is the use of sending start and end of the frame. Okay, so in this diagram, I mean for frame, so we are using the so we are going to compose the protocol dependent special characters signals he start at end of the frame, at the start and end of the frame. The format of the frame is character oriented protocol. So in this character oriented protocol, the framing was popular when only text has exchanged by the data link layer. So what is mean by, so framing, in this whatever the text we are using, that can be exchanged in the data link layer. The flag could be selected to be any character not used for text communication. So we send other type of information such as graphs, audio and video. So any pattern that can be used for flag could also be part of the information. So whatever the information used by the flag, that is also a part of the frame, are part of the information. So the receiver, when it encounters the pattern in the middle of the data, it thinks that it's reached at the end of the frame. To fix this problem, byte stuffing strategy was added to the character oriented protocol, added to the character oriented framing. So in the byte stuffing, so a special byte is added to the data section. A special byte is added to the data section. So this is the character oriented protocol. So this is the diagram. So I think already I have discussed about this topic. So I am just recollecting these points. Okay. So this is the diagram of the character oriented protocol. So this is my flag data. So this is my format of frame format, that is I having the end and beginning and end of the for frame, I having the flag. So and I am using the header, trailer and some other informations that are available, some other variables are available in between this frame. Okay, so I am going to stuff the bits like flag and escape. So I am using the flag and escape. So this is the data from upper layer, so the data is stuffing into the frame. So again I am stuffing 2 extra bits, that is called 2 escape characters. Okay, so after getting at the receiver, at the sender side, I am doing these procedures all. So I am stuffing the data from upper layer information, that is flag and escape, in the original data, that is original frame. So after stuffing that, I am again stuffing 2 extra bits, that is called extra 2 bytes, that is escape characters. And at the receiver, when we send that data to the receiver, whenever we send that data at the receiver side, so the whatever we have stuffed, that is unstuffed from that at the receiver, and whatever the original data we are having in the sender side, so that will be received to the receiver. So this is the working of character oriented framing. So next coming to bit oriented framing. So what is mean by bit oriented framing? So in this before going to bit oriented, so this, if see this diagram, so in this diagram we having the escape character. So in this 1 byte stuffing or character stuffing, a special byte is added to the data section of the frame when there is a character with the same pattern as a flag. The data section is stuffed with the extra byte. The byte is usually called as escape character, so which is predefined bit. So the receiver encounters the escape character, it removes from the data section and treats the next character as a data, not to delimiting flag. So byte stuffing is the escape character allows the presence of flag in the data section of the frame. So but it creates the another problem. When it happens, the text contains one or more escape characters. The receiver removes the escape characters but keeps the flags, which is incorrectly interpreted at the end of the frame. To solve this problem, the escape that are the part of the text must be marked by another escape character. So in this escape character is a part of the text. We adding the extra one is added to show that second one is a part of the text. So this, in this character oriented protocol, we have present another problem in data communication. So the coding system is used today, such as Unicode have 16-bit and 32-bit characters to conflict with 8-bit characters. We say that tendency is moving towards the bit oriented protocol, that is called the bit oriented protocol. Now we are going to about the bit oriented protocol. So in this bit oriented protocol, the data sections of a frame is a sequence of bits. So whatever the frame we are taking, in that data, the data section, the frame of in that frame, the data section is in sequence of bits. The bits are allocated in the sequence of bits to be interpreted by the upper layer as text, graphic, audio, video, and so on. So the header, at the header it is possible the trailers. So if we have used the header, we should have the trailer also. So we still need to delimiter to separate one frame from another. Most protocols uses the special 8-bit character, 8-bit pattern flag, that is 0 1 1 1 1 1 1 0. So this is my bit. Okay, this is my pattern, 8-bit pattern flag I am using. So as a delimiter to define the beginning and end of the frame. So this is the diagram. In this diagram, if you see that we are using the 8-bit pattern in a sequence order. So this is my bit 0 1 1 1 1 1 1 0. This is my flag. So at the beginning and end of the flag, both I am using the 8-bit sequence or 8-bit pattern. So if the flag create a same type of problem, we say in the byte oriented protocol. So if the flag pattern appears in the data, if the flag pattern appears in the data, we need to inform the receiver that is not the end of the frame. So we have to we are going to stuff the one single bit. So in this so in the previous character oriented protocol, we are going to stuff the characters. So escape character and flag. So these types of characters I am going to stuff in the character oriented protocol. So we are going to now we am talking about the bit oriented protocol. In this we are going to stuff only a one bit values, one bit or like a single bits like 1 0, this, like we are going to stuff that bits in the bit oriented framing. So in this we have to stuff the one single bit instead of 1 byte to prevent the pattern from looking like a flag. The strategy is called a bit stuffing. So in bit stuffing is if a 0 and 5 consecutive one bits are encountered, and so in what we in the flag, what we have bits, we have 0 and 5 consecutive 1 bits are encountered, and extra 0 is added encountered sorry so the so an extra 0 is added to the flag, and the extra whatever the bits we have stuffed in the sender side. At the receiver side, with the stuffed bits is removed at the receiver. So the extra bits is added after the 0 and followed by the 5 consecutive regardless of this value of the next bit. So this is fag field sequence does not appear in the frame. So this is called the bit oriented protocol. So in this we are having the bit stuffing at the sender and bit removal at the receiver. That means that even if we have 0 after 5 ones, we still stuff 0, then the 0 will become removed by the receiver. So this is the bit oriented. This is the diagram of the bit oriented. So in this bit oriented, so if you see this diagram, we can understand the whatever explanation I have given. So this is my frame. In this frame, at the beginning and end of the frame, both sides are having the flag. So it is the starting and end of the indication of the flag. And at the middle we have at the left side we are having the header, at right side we are having the trailer. So in this header we are having the source and destination address and other information whatever we are having, so that will be available in the header. Trailer is nothing but it is mainly used for detecting and correcting the errors. Okay na? First of all we are going to detecting and correcting the errors, that is called the trailer. So middle of it are having the extra variables of bits in variables of space. In that we are going to stuff the data. The data from upper layer I am going to stuff. So this is my data. So in this data I am going to stuff the extra bits. So okay na? So this is my data I am stuffing in the sender side. After stuffing I am using to add another 2 extra bits in this stuffing bits. So at the sender after stuffing all the bits in the sender side, it will be sent to the transmission medium and it will be received at the receiver side. Okay na? So whenever it received at the receiver side, whatever we have stuffed the bits in the sender side, that will be removed at the receiver side, and whatever the original data having, that is reached to the receiver. So this is called the bit oriented. In the character oriented we are going to stuff the characters, in the bit oriented we are going to stuff the bits. So this is the difference between bit oriented and character oriented. So next coming to flow control and error control. So what is meant by flow control? So data communication requires at least 2 devices working together, one to send and other to receive. Such basic arrangement requires a great deal of coordination for intelligible exchange to occur. So between the data source and destination, we have to provide the communication, data communication. So least 2 devices will be communicate with each other. So in this we are having the some basic arrangement that can be required to deal the coordination for the exchange of data can be occurred. Most important responsibilities of the data link layer are flow control and error control. Collectively these functions are called data link control. So coming to main use of flow control, the flow control coordinates the amount of data that can send before receiving acknowledgement, and in the acknowledgement is one of the most important duties of the data link layer. So what is mean by data link layer ma? So sorry, flow control. So in the flow control, whatever the data we are sending at the receiver side, so without getting acknowledgement it will send the again next data. Flow control means, so one side, so this is the diagram. If you see the diagram you can understand. So this in this we are having in this flow control, whatever the data we are having at the sender side, that the sender will send the data before receiving the acknowledgement from the receiver. And is one most important duty is the data link layer. The most protocol flow control is a set or procedure set of procedures that tells the sender how much data is to be transmit before it must wait for an acknowledgement from the receiver. The flow of data must not allowed, and at the receiver, any receiving devices has limited speed at which it processes the data and limited amount of memory in which the store the incoming data. So this is called flow control. So next coming to error control. So error control is both error detection and correction. It allows the receiver to inform the sender of any frame lost or damaged in transmission and coordinates the retransmission of those frames by the sender. So in the data link layer, the error control refers primarily to methods of error detection and retransmission of error control. So what is mean by error control, ma? So error control is nothing but both error detection and error correction will be occurred. So the receiver inform the sender any frames are lost or damaged in the transmission. So whenever we are sending the data from one node to the another node, the receiver will be the second node who are receiver. So that node will be informed to the sender. So whatever the data lost or damaged in the transmission. So the again that sender will be retransmit the frames by the retransmitted. And the data link layer in the term error control refers to be a methods of error detection and retransmission. Error control in the data link layer is implemented simply at any time an error is detected in an exchange. Specified frames are retransmitted. This process is called auto repeat request. Error control in the data link layer is based on auto repeat request, which is retransmission of data. So this is called the error control. Next, coming to the connectionless and connection oriented. So in this we are having the two types, that is connectionless protocol and connection oriented protocol in the data link control. So data link control protocol. So what is mean by connectionless? In the connectionless protocol, frames are sent from one node to the another without any relationship between the frames. Each frame is independent. That is the connectionless protocol. Next, connection oriented protocol. In the connection oriented protocol, whatever the frames we are having, that frames we are going to number, that is called sequence numbers, and sent in order. If they are not received in order, the receiver needs to wait for until an frame belonging to the same set are received and deliver them in order to the network layer. So this is called the connection oriented protocol. Next, coming to the data link protocol. So in the data link protocol we are having two types, that is noiseless channel and for noisy channel. So in the noiseless channel, I told that we are having two types, that is simplest stop and wait protocol. In the noisy channel we are having three types, that is stop and wait ARQ, automatic repeat request, stop and wait, automatic repeat request, go back, and ARQ, automatic request, automatic repeat request. Next, the third one, selective repeat ARQ. These are the three types available in the noisy channel. Next, coming to first one, in the noiseless channel we are having first one, simplest protocol. So what is mean by simplest protocol? First protocol we call the simplest protocol, for lack of any other name, is one that has no flow and error control. So the other protocols, it is a unidirectional protocol in which data frames are traveling in only one direction. It is a unidirectional protocol in which data frames are traveling in only one direction. If you see this diagram, you can understand very easily. At the sender we are having sender and receiver, and we are transmitting the data frames that in the one direction. So we can say it is a unidirectional protocol which data frames are traveling in only one direction from sender to the receiver. So we have to assume that the receiver are immediately handling the any frame it receives with a processing time that is small enough to be negligible. The data link layer of the receiver immediately removes the header from the frame and adds the data packet to its network layer, which can also accept the packet immediately. In other words, the receiver can never take the incoming frames. So in this we are having the design. So there is no need to flow control in this scheme. So the data link layer at the sender side gets data from its network layer and makes a frame makes a frame out of the data and send it. So the data link layer at the receiver side receives the frame and it is and receives and frame from its physical layer. So what is the design of this simplest protocol? So we don't have any flow control scheme in this simplest protocol. So the data link layer at the sender side gets the data from its network layer. From network layer to it will get the data. So what is we are having sender here? The sender will be get the data from the data link layer. network layer, and make the frame out of the data, and it sends to the receiver. So the data link layer at the receiver side, that receives the frame from the physical layer and extracts the data from the frame, and it delivers the data to its data link layer, and data link layer of the sender and receiver provide transmission service for the network layer. So what is the communication here occurring? See, if you see this diagram, you can understand. So what we are having here, sender we are having data, having some information at the sender at the sender side, the data will be transmitted to the network layer. So network layer నుంచి డేటా అనేది నెట్వర్క్ లేయర్కి మూవ్ అవుతుంది. సో సెండర్ దగ్గర ఉన్న డేటా ఇక్కడ మూవ్ చేసినప్పుడు నెట్వర్క్ లేయర్కి వెళ్తుంది. సో నెట్వర్క్ లేయర్లో మేక్స్ ఫ్రేమ్స్. So whatever the data in the network layer having, the data is in the format of in which format, in the packet format. In the network layer, the data will be in the packet format. The packet format is moves in the next, that is data link layer. So it is in the format of frame out of the frame out of data. So and it sends to the data link layer. సో దట్ ఆ డేటాస్ని డేటా లింక్ లేయర్కి మూవ్ చేసినప్పుడు రిసీవర్ ఆఫ్టర్ రిసీవింగ్ ద డేటా లింక్ లేయర్ అండ్ ద ఫ్రేమ్స్ విల్ బీ మూవ్స్ టు ద సెండ్ టు ద ఫిజికల్ లేయర్. సో సెండర్ దగ్గర డేటా ఉంటుంది, డేటా లేయర్ విల్ బి సెండ్స్ టు ద నెట్వర్క్ లేయర్ కన్వర్ట్స్ అండ్ process that data in its format, and after that it sends to the data to the data link layer, and data link layer also process whatever the format available in the data link layer. It turns in the form of data in the format of packets or any other frame, and it will be moved to the physical layer, and in the physical layer whatever the data format we are having, what is the format of the physical layer, it in the format of bits. So after that the bits is converted, and the frame is converted into bits, and the data is transmitted to the receiver. So at the receiver side, the receiver received in the form of physical, that is in the zeros and ones bits. After the data will be transmitted to the data link layer, the data conversion will be converted in the data format, frame format. After that the frame converted into network format, and it will be delivered to the receiver. This like the communication will be occurred in the simplest mechanism. So in this such as we are using signaling and multiplexing and so on for physical transmission. For this physical transmission, we are going to use the signaling or multiplexing. Okay, in this this is the main working of this diagram. So in this we are having elaborate on the procedure used both data link layer. At the sender side cannot send the frame until its network has the data packet to send. The receiver side cannot deliver a data packet to its network layer until the frame arrives. If the protocol implemented as a procedure, we need to introduce the ideal events of the protocol. So in this procedure, the sender side is constantly running. There is no action until there is a request from the network layer. This procedure at the receiver side is also constantly running. So there is no action until notification from the physical layer arrives. Both procedures are constantly running because they are not known with each other, and corresponding events will be occur. So in this we are having this is the flow diagram of the simplest protocol. So in this flow diagram, so the communication using this the communication will be used this protocol is called, we having set of rules, we have to follow that rules, and we have to send the data from one node to the other node. It is very simple. The sender sends the sequence of frames. So we are sending the sequence of frames without even thinking about the receiver. So we don't think any about the receiver. The receiver is received that so receiver, whatever the sender send the data, that received by the receiver or not, we don't have any observation or thinking about the receiver. We just send the data, frames from the sender in the sequence order. So okay na, so we have to send the we are going to send the sequence of frames without even thinking about the receiver. The sender to send the 3 frames, in this diagram I am sending the 3 frames here without thinking about the receiver, that is arrived at the receiver or not. 3 events occur at the sender side, and 3 events occur at the receiver side. So note that the data frames are shown in the title box. The data frames are shown in the title box, and the height of the box defines the transmission time difference between first bit or the last bit in the frame. So this is the simplest flow diagram. So a flow diagram is nothing but in the simplest. So whatever the data we are having at the sender side, that can be sent sequentially without stopping. So at the receiver side, the receiver doesn't observe, and he doesn't the user doesn't think about the receiver, the data whatever we have sent, that is received at the receiver or not. It just sending the data in the sequence way. Okay, now this is called the simplest way of flow diagram. Next, coming to the stop and wait protocol. So in this stop and wait protocol, still we have in this stop and wait protocol, the data frames arrive at the receiver side faster than than they can proceed. The frames must be stored until their use. So the receiver does not have enough storage space, especially if it is receiving data from many sources. So this may result in either in discarding the frames or denial of frames. So it is nothing but stop and wait protocol is nothing but, so whatever the data frames we are having at the receiver side, that is faster that can be processed. Okay na? So the frames must be stored until their use. So whenever we are using if you having the number of sources and one receiver, so the receiver doesn't handle that much of data frames in the storage. So the result either will be, it will discard the frames and delete the service. So it will be terminate the service to prevent the receiver from the beginning with the frames. So how need to tell the sender to slow down. So sender is sending continuously data to the receiver. So we can say we have so many sources. So due to that so many sources, so every sources will be send the data to the receiver. So due to the overflow of data, so number of data is arriving at the receiver side. So the receiver will be unable to store that data. So due to that some it will be discard the data or frames, and it will be terminate the service completely. So to prevent that receiver beginning overwhelmed with frames, somehow how need to tell the sender to slow down. So there is must be a feedback from the receiver. So అందుకని సెండర్ నుంచి రిసీవర్కి డేటా అనేది మనం సెండ్ చేస్తాం. సో సెండర్ నుంచి డేటా అనేది మనము రిసీవర్కి పంపిస్తున్నాం. సో రిసీవర్కి రీచ్ అయిందా లేదా అనేది మనము అబ్జర్వ్ చేయాలి. సో రిసీవర్ రీచ్ అయిన తర్వాత receiver should be give the reply to the receiver. So I have reached that data. So I have reached that data, and I'm waiting for the another data. You can send that. So that like communication will be is there, means we don't have any occurrence of loss of data and collision of data, and we are unable to discard also that data. So in order to avoid the problems, we are using the stop and wait protocol. So in this stop and wait protocol, we are having the acknowledgement. So first sender will be send the data to the receiver. After receiving the data at the receiver side, receiver send the acknowledgement to the sender that I have reached that data what you have sent. So that again after getting the acknowledgement, the sender will be send the next data to the receiver. So this like the communication will be occur. If the receiver doesn't get any data whatever the sender send, so the receiver will be send the negative acknowledgement that I have doesn't get any data from you. So then receiver will be, and I mean sender will be send again the same data until he get acknowledgement from the receiver. So this is called the stop and wait protocol. So in this communication, the protocol we have using some protocols called the stop and wait protocol, because the sender sends one frame and stops until the receives the confirmation from the receiver. So it sends the one frame to the receiver. So until that the sender waits, it doesn't send another frame in sequentially. It waits for some time that receiver received the data or not. After knowing that information, then he send the next frame. We still have unidirectional communication for data frames, but auxiliary acknowledgement frames, simple tokens of acknowledgement travel from from the other direction. So we add flow control to our previous protocol. So this is the design of the diagram, that is stop and wait protocol, and in this I having the sender, I am sending one frame to the receiver. So receiver will be check he is arrived, the user will be check the receive at the receiver the data is received or not. If the receiver received that frame from the whatever the sender sent, it will be send, the receiver will be send the acknowledgement to the sender. After receiving the acknowledgement by the sender, again it will send the frame to the receiver. The receiver receiving the frame and he will send the acknowledgement to the receiver. So this like the communication will be occurred. If the receiver doesn't get any information from the sender, it will send the negative acknowledgement. So okay, this is the communication occurrence in the stop and wait protocol. This is the flow diagram. Okay, next to noisyless channel. So up to in the stop and wait protocol we having two types, that is a simplest and simplest protocol and stop and wait protocol. Now I am talking about the noisy channel. So what is mean by noisy channel? So in this noisy channel we are using stop and wait protocol that gives us the stop and wait protocol whatever we are discussing in the noiseless channel, that will be gives the ideas how to add a flow control and its procedure. Noiseless channels are no existent, we can ignore the errors or we need to add the control error to our protocols. So in this we are having three types I told in the previous, that is stop and wait, automatic repeat request, so this is the stop and wait automatic repeat request. So we can say ARQ. Okay, so sender keeps, so in this communication, so our first protocol called stop and wait automatic repeat protocol, it sends it adds a simple error protocol mechanism to stop and wait the protocol. So how this protocol detects and corrects the errors? So to detect and correct the corrupted frames, we need to add redundancy bits to our data. So what is the mean of stop and wait ARQ? So in this protocol, how we are going to detect and correct the errors? So in this correcting and erecting in this error, in order to detect and correct the corrupted frames, we need to add the redundant bits at the at our data frame. When the frame arrives at the receiver side, we have to check it is corrupted or not. It is silently discarded the corrupted bits and corrupted bits, and the detection of errors in this protocol is manifested by the silence of the receiver. The lost frames are most difficult. To handle than corrupted ones. So our previous protocol, the no way in to identify the frame. In the previous protocol, we don't have any way to identify the frame. So the receiver frame could be correct one, could be correct one, or duplicate, or the frame out of order. So this solution is have number of frames. So when the receiver receives the data frame that is out of order, this means the frame were either lost or duplicated. So the complete and lost frames need to be resent in this protocol. So the complete loss, if you have lost any data, or data will be collapsed, or data will be frames will be resended again. Okay, so whatever the data we are having sent from source to destination, in this communication, if the data will be lost, the data will be resended by using the protocol. So that is ARQ. So automatic repeat request, if the receiver does not respond, then there is an error. So whenever we are send the data from the source, that is the receiver doesn't respond, we think that there is something. So if the sender send the data ni send చేసినప్పుడు రిసీవర్ ఏం చేస్తుంది, acknowledgement ని పంపిస్తుంది. అగైన్ సెండర్ అనేది డేటాని పంపిస్తాం. సో ఇలా కమ్యూనికేషన్ జరుగుతుంది. సమ్ టైమ్స్ ద రిసీవర్ డజంట్ రీచ్ ఎనీ ఇన్ఫర్మేషన్ ఫ్రమ్ ద sender. The receiver will be send the negative acknowledgement that I have doesn't reach any data. So if it doesn't send any acknowledgement, any negative acknowledgement, then we can then think that at the receiver there is some error. So how can the sender knows which frame to resend? So sender how will be identify whatever the frames we have sent, in which frame the data will be lost, how to we have to recognize that. So we have to remedy this problem. The sender keeps a copy of sent frame. So the sender keeps the copy of sent frame. The frame is resent, the copy is held, and the timer is restarted since the protocol uses the stop and wait mechanism. There is only one specific frame that needs an acknowledgement even through several copies of the same frame can be in the network. So the error correction in stop and wait protocol is done keeping a copy of the send frame and retransmitted of frames when the timer expires, since the acknowledgement frame can also corrupted and lost. So what does it mean? So whenever we are sending the data to the receiver side, and we have to provide some limited amount of time at duration. So within that duration, whatever the data we have sent, that should be reached to the receiver. If the data is not received at the receiver side within a given time, so the we think that there is some problem will be occurred in the communication. So we can again retransmitted the data whatever copied in the network. So the correction in the stop and wait protocol is keep copying the send keep copying of the send frame and retransmitting the frame. When the time expires, an acknowledgement frame can also be corrupted and lost. It too needs redundancy bits and sequence numbers. The acknowledgement frame for this protocol has sequence numbers field. So what it is saying means, so whenever we are sending the data from the sender to receiver, so every frame stop and simplest mechanism lo manam data sequence format lo pampicham. So one by one we have sent the data, but we doesn't have any observation on the receiver which is received on whatever the data we have sent, that is reached at the receiver or not. We doesn't think any about receiver. We just sending the data in the simplest protocol, simplest mechanism. In this communication stop and wait ARQ, whatever the data we are sending, so first I send first two frames. So the receiver first I send first frame 1. So that frame 1 is reached to the receiver. The receiver will send the acknowledgement to the sender. After the sender receiving the acknowledgement, again the sender will send the frame 2. Frame 2 also reach it to the receiver. The receiver will be send the acknowledgement to the receiver. So this like the communication will be occurred. So if the frame 2 is not received, sometimes the frame 2 is not received at the receiver will be send the acknowledgement, negative acknowledgement that I doesn't reach anything. So in sometimes if we reach it to the receiver, so it doesn't send any response to the receiver, I mean sender. So we think that there is some the error will be occurred at the receiver side. This is one thing in the communication. So in order to avoid that, we have to provide the every frame we have to provide the sequence number, because we have to know which frame is have lost, which frame is damaged, and we have to know that. So in order to know that problem, we have providing the sequence numbers. We have providing the sequence numbers. So whenever the data is having for that frame acknowledgement frame is protocol has a sequence numbers field. In this protocol the simply this discards the frame and corrupted. Okay, in this frame we are having the in this protocol the sender simply discards a corrupted acknowledgement frame or ignores the out of order one. So this is the stop and wait protocol. In this we are having the sequence numbers for every frame. So the protocol specifies the protocol in this we are having the protocol. This protocol specifies that frames need to be numbered. So whatever the frames we are having, for that frames we are providing the sequence numbers like frame 1, frame 2, frame 3, this like. Okay, so we are providing the frame numbers. And in this using the in this field is added the data frame to hold the sequence numbers of the frame. One important consideration is that the range of sequence numbers. So that we have to use the range of sequence numbers. We want to minimize the frame size, we look for the smallest range to provide the unambiguous communication. The sequence numbers of wrap around, for example, we need to decide that a field is m bits long. The sequence number starts from 0 to the m to m minus 1 and then are repeated. So in this reason, the reason of the range of sequence number is we have to assume we have used the x as a sequence number, and we only need to use x plus 1. After that there is no need for x plus 2. We have to assume that the sender is sent the frame numbered x. three things can be happen. So one is the frame arrives safe. The frames arrive safe. The frames will be arrive safe. At the receiver side, the receiver sends an acknowledgement. The acknowledgement arrives at the sender side, so causing the sender to send the next frame number, that is x plus 1. That is the first occurrence of the occurrence between the sender and the receiver. So another occurrence is called the frame arrives safe and sound the receiver side. The receiver sends the acknowledgement, but the acknowledgement is corrupted or lost. The sender resend the frame that is numbered x. After timeout, note that the frame here is a duplicate. The receiver can recognize this fact because it accepts frame x plus 1, but frame is x was received. So depending on the this identification of x plus 1x, we can identify which data is lost and which data is received at the receiver. So this is the second occurrence will be happen. So next, the frame is corrupted or the frame is corrupted. The frame is corrupted or never arrives at the receiver side. The sender resend the frame. The sender resend the frame that is numbered x. After timeout, we can see there is no need for sequence numbers x and x plus 1 because the receiver needs a distinguish between case 1 and case 2, but there is no need for frame to be numbered x plus 2. So in case 1, the frame can be numbered x again because frames x and x plus 1 are acknowledged and there is no ambiguity at either side. In case 2 and 3, the new frame x plus 1 and x plus 1 and not x plus 2. If only x and x plus 1 are needed, we can let x is equal to 0 and x plus 1 is equal to 1. This means that the sequence is 0 1 0 1 0 and so on. So in the stop and wait ARQ, we use the sequence numbers to number the frames. The sequence numbers are based on module 0 to arithmetic. So in this we are having the acknowledgements. We have told that we are using and we are maintaining the acknowledgement between sender and the receiver. So since sequence numbers must be suitable for both, sequence number must be suitable for both data frames and acknowledgement frames. We use this conversation. This acknowledgement numbers also announce the sequence numbers of next time. సో ఎక్నాలెడ్జ్మెంట్ నెంబర్ మీన్స్ వాట్ మా, సో సెండర్కి రిసీవర్ మధ్య కమ్యూనికేషన్ అనేది జరుగుతూ ఉంటుంది. సెండర్ అనేది సెండ్ చేస్తాము రిసీవర్కి, రిసీవర్ విల్ బి గెట్ ద డేటా ఇన్ ద ఫార్మ్ ఆఫ్ సీక్వెన్స్ నెంబర్స్. సో ఫ్రేమ్ 1, ఫ్రేమ్ 2, ఫ్రేమ్ 3, దిస్ లైక్. సో ఫర్ ఎవ్రీ ఫ్రేమ్ we are providing the acknowledgement frame. So both the data frames and acknowledgement frames we are use the conversion. So these acknowledgement numbers always announce the sequence numbers for the next frame expected by the receiver. For example, if frame 0 has arrived safe and sound, the receiver sends an acknowledgement frame with acknowledgement 1 meeting frame 1 is expected next. So if frame 1 has arrived safe and sound, the receiver sends the acknowledgement frame to send the acknowledgement 0. So this like the communication will be occur. So this is the sender and the receiver, and this is the diagram. So this is the R0 S0. Okay, so this is the source and sender and the receiver. So sender ఇది వచ్చి సెండర్, ఇది రిసీవర్. సెండర్ ఏ ఫ్రేమ్ పంపిస్తున్నారు, ఫ్రేమ్ 0 పంపిస్తున్నారు. సో CM 0 అనేది రిసీవ్ అయింది. రిసీవ్ అయిన తర్వాత ఏం జరిగింది, డెలివర్ అయింది, రిసీవర్కి రీచ్ అయిపోయింది. సో రిసీవర్ రీచ్ అయిన తర్వాత మళ్ళీ ఏం పంపిస్తున్నాడు, R1 అనేది పంపిస్తున్నారు. R1 అంటే ఏంటి, ఎక్నాలెడ్జ్మెంట్ అనమాట. మీరు పంపిస్తున్న డేటా నాకు రిసీవ్ అయింది, ఓకే, రిసీవ్ అయింది అని చెప్పి ఎక్నాలెడ్జ్మెంట్ ద్వారా దానికి తెలియజేస్తున్నాడు, సెండర్కి తెలియజేస్తున్నాడు. ఐ హ్యావ్ రీచ్డ్ యువర్ డేటా, ఐ హ్యావ్ యూ వాట్ ఎవర్ ద డేటా యూ సెండ్, ద డేటా ఈస్ రిసీవ్డ్ టు మీ అని ఎక్నాలెడ్జ్మెంట్ పంపిస్తున్నాడు. సో ఎక్నాలెడ్జ్మెంట్ రిసీవ్ అయిన తర్వాత సెండర్ ఏం చేస్తున్నాడు, ఫ్రేమ్ సెండర్ ఏమని పంపిస్తున్నాడు, R is equal to 1 అంటున్నాడు. R is equal to 1 అంటే ఏంటి, మీరు 0 పంపించేశారు కదా, నెక్స్ట్ ఫ్రేమ్ 1 పంపించండి అని చెప్పి ఎక్నాలెడ్జ్మెంట్ ఇచ్చి, ఎక్నాలెడ్జ్మెంట్ వచ్చి దేనిది, ఫ్రేమ్ 0ది ఎక్నాలెడ్జ్మెంట్. 1 అనేది వన్ అనేది ఇంకో ఫ్రేమ్ వన్ పంపించండి అని చెప్పి పంపిస్తున్నాడు. సో ఏం చేస్తున్నాడు మా, జీరో ఫ్రేమ్ పంపించినాను, జీరో ఫ్రేమ్ అనేది రిసీవర్కి వెళ్ళింది, రిసీవర్ రీచ్ అయిన తర్వాత ఎక్నాలెడ్జ్మెంట్ పెట్టింది. ఎక్నాలెడ్జ్మెంట్ ఏసీకే అనేది ఎక్నాలెడ్జ్మెంట్ దేనిది, ఫ్రేమ్ జీరోది. వన్ అనేది ఇంకో ఫ్రేమ్ పంపించండి అని చెప్పి రిక్వెస్ట్ పెట్టడం. సో ఎస్ ఈజ్ ఈక్వల్ టు 1 వీ హ్యావ్ పుట్ హియర్ ఎస్ ఈజ్ ఈక్వల్ టు 1, దట్ ఎస్ ఈజ్ ఈక్వల్ టు 1 ఈజ్ రీచ్డ్ టు ద రిసీవర్. So this is the s is equal to 1. Frame 1 is delivered at the receiver side. Again the receiver sending that r is equal to 0. So that acknowledgement is received. So whatever the frame you have sent, I get that data at the receiver. Now send the next frame. Like that he is sending the acknowledgement to the sender. So this is the working of this acknowledgement stop and wait ARQ. Next coming to go back and ARQ, automatic repeat request. Go back, okay, this is the communication ma. So in this we have to improve the efficiency of transmission. Multiple frames must be transmitted while waiting for acknowledgement. So go back and automatic repeat request. So what is mean by, in this we have to improve the efficiency of transmission with multiple frames must be transition while waiting for acknowledgement. In other words, we need to have more than one frame be understanding to keep the channel busy while the sender is waiting for acknowledgement. In this section we discuss one protocol that can achieve this goal. The next section we discuss the second. The first is called the go back and automatic repeat request. So in this protocol we are send the several frames before receiving an acknowledgement. So acknowledgement rakamundane so many numbers anedi so many data we have sent it to the receiver, okay na. So other several frames before receiving the acknowledgement we have sent this to the receiver. We keep a copy of this. So whatever the data we have sent at the receiver, we have kept the copy in the that frames copy we have kept until the acknowledgement arrive. So okay, so whatever the data we have sent from the sender, we have sent the multiple frames one after another without getting the acknowledgement from the receiver, and whatever the data we have sent, that copy is kept in the sender, and it will be wait until the acknowledgement arrives to the sender. So sequence numbers, frames from the sending station are numbered sequentially. So every data we have provided, every frames we are providing the sequence numbers. So because we need to include the sequence numbers of each frame in the header, so we need to send the limit. If the header of the frame allows m bits of sequence number, the sequence numbers range from 0 to 2m-1. For example, if m is 4, the only sequence numbers are 0 through 15 exclusive, and we can repeat the sequence. The sequence numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and up so on. And in other words, the sequence numbers module 2 power m, okay. In the go back n protocol, the sequence numbers are module 2 power m, where m is the 0 size of the sequence number field in bits. So this is called the sequence numbers. Next, sliding window. So what is mean by sliding window in the go back and ARQ? So in this protocol we are using the sliding window in an abstract concept to define the range of the sequence numbers, and in this concern the sender and the receiver. In other words, the sender and the receiver need to deal with only the part of possible sequence numbers. The range which concern of sender is called the sender sliding window, okay. The range in this receiver is called the receiving sliding window. So we both discuss here. The sender window is an imaginary box covering the sequence numbers of the data frame which can be transmitted. Each window positions some of the sequence numbers define the frames we have been sent. So other define that can be sent. The maximum size of the window is 2m-1. For the reason we have the size to be fixed and set the maximum value, but we will see in the future what the protocols may be variable and window size. So this is the main of the sliding window. Sliding window means we are shifting from one bit to the another bit, moving, okay. Sliding window protocol, okay. I am using the bits that is 0 to 14. So I am going to this is the sliding window. In this sliding window I am shifting the bits from one place to the another place. Okay, so I having 0 and 2 have been acknowledged. Okay, so send the window first to outside frame, and send the window next frame to send. Okay, so this is called the sliding window protocol. Okay, in the next class we will discuss the next one, ma. So that is selective repeat selective repeat automatic repeat request. Okay, so in the next class we will discuss about the selective repeat. Okay. So up to here in these protocols, I told that the noiseless channel and for noisy channel. So we have discussed about the noiseless channel. In this we are having two types, that is simplest protocol and stop and wait protocol. In the next one, that is for noisy channel, we are having three types, that is stop and wait ARQ and go back NRQ. So these two topics now we have discussed. In the next class we will discuss about the selective repeat ARQ. Okay. So thank you, ma. Thank you.